Okay, here we are on page 1 and we're going to be dealing with interest. Notice that there are a couple of different formulas. Find the missing numbers. Good. Simple interest has this formula where the interest rate is not being compounded over and over again, so we don't get an exponent. And then we have this more complicated formula down here where we have the exponent and it's compounded interest. So simple interest, number 1, is going to follow this formula up here. So we have the amount is going to equal 200. That's our P. 1 plus 0.08 times 15. And we're just going to put that in our calculator. So let's type that in. 200 times 1 plus 0.08 times 15, enter, and we get 440. So there we go. Number 2. This one is compounded and it's compounded quarterly, so n is 4. So here, number 2 is going to look like this. We're going to have 200 and then 1 plus 0.08 divided by 4. There's our n down there on the bottom. And then it's all raised to the 4 times 15. So notice there are going to be 60 compoundings all the time. Let's punch this one into the calculator and see what it looks like. So we get 200. Now we've punched in the 1 plus 0.08 divided by 4. So that's our periodic interest rate. And then we're going to take that to the 4 times 15. Now you could do that in your head and have a 60 there, but just so that it looks exactly like what's going on there, be sure that exponent is in parentheses. And we get 656.21. Now notice how much more that is because the interest gained interest for 15 years. 656.21. Good. Monthly. So number 3 is going to look a little bit different. And it's going to be where we're starting with $200. We still have the 8% interest, but in this case, we're going to divide it by 12 and do every month we're going to have a compounding. So when we stick this guy in, it's going to be almost exactly the same thing. Here's a little trick on this TI calculator. Do second entry, and I get that whole thing back. So let's scoot right here and do insert that little 12 there and go to the 12 times 15. So insert one of these and then put a 2 times 15. Oh, the insert button didn't work there. So we've got the exact same thing we had before, but now we're taking a smaller interest rate but compounding it more often. And what do we get there? 661.38. Now notice the compounding. The interest getting interest is a huge jump. This is a smaller jump, compounding more often. Now we're going to do daily. N equals 365. Let's see what this guy looks like. So number 4 is going to be 200. 1 plus 0.08, still 8% interest rate, over 365 days every year. And now we'll take 365 times 15. Whew. So use that again, second entry. So type all that guy in again, but this time we're going to go back up here and replace that 12 with a 360. I better use the insert button, 5 to move everything down. And then let's go back down here to the 12 and do 3, 6, and insert 5. There we go. We've typed it in again, and we get 663.94. And notice we're now compounding almost always now. And so we see we're getting more and more the more often we compound, and then eventually we get to what's called continuous compounding, but that's not for this particular section. All right, let's do number 5. So number 5 is simple interest. So here, notice that we have to find P. So we know that we've got 13,000, and it's going to equal P times 1 plus 0.043 times 17. Excellent, good. And so now we've got to find out what P is, which means in this case we won't be using the calculator. We're going to, well, not immediately, not punching it in, but dividing. So P is going to equal to this 13,000 divided by 1 plus 0.043 times 17. All right, let's punch that in and see what we get. We get 13,000 divided by parentheses 1 plus 0.043 times 17. Close those parentheses. And 7510. So this is saying that if you start off with $7,510.11, and this interest rate for this long, you'll end up with $13,000. Alrighty, number 6. Notice we're now using the more complex formula, but it's still the same idea. We ended up with $1,700, and that equals this P, which is a variable, 1 plus 0.06 all over n equals 4. We're quarterly right now. All to the 4 times the number of years is 5. Wow. So we got to punch all this in the calculator and then divide 1,700 by it. Let's do that. Punch in 1 plus 0.06 divided by 4. And all that gets taken to the 20th power. Could have done 4 times 5. And we get 1.34. And now we need to take 1,700 divided by that. So I'm going to write that over here. 1,700 divided by that 1.34 is going to equal the P. That's algebra, dividing that guy over. And we get 17. Ooh, I guess that's a 1.35. We should write that in, 1.35. So 17 divided by second answer. So we can go ahead and use the A and S right there, and we get 12.62. Ha! I did need to do 1,700 divided by that 1.346855, etc. There we go. That makes more sense. $1,262.20. So that's $1,262.20. Good. And we have there. All right, number 7. Monthly, n equals 12. So we're going to have the same thing. We're ending up with $150,000. And that's going to equal the original principal, 1 plus 0.09 all over monthly is 12, all to the 12 times 40. That's going to be 480 in the exponent there. And see what happens. So it's going to be 150,000. Let's punch this guy in and see what we get. 1 plus 0.09 divided by 12. And enter that. Take that to the 12 times 40. That's 480 power. Whoa. And then we're going to take 150,000 divided by that number. So second answer. And we get 4153.99. 4153.99. Which is actually where you can see the power of interest. If $4,000 left for 40 years in the stock market, or something that'll grow at an average rate of 9 or 10%, will end up at $150,000 after 40 years. Time is really the benefit with interest rate. All right, number 8. So the last one that we're going to do up here before using the solver. So we are at $75,000 is where we're ending. And we've got to get some principal, 1 plus 0.115 over 365, all to the, 365 is n times y is 25. Wow, that's a huge number there. So I'll plug this in the calculator and we get 1 plus 0.115 divided by 365. So you'll notice that becomes a very small daily interest rate that we get, but now we're raising it to the 365 times 25. So a huge power, and we get 17. So we've got to divide 75,000 equals P times 17.7. So we divide off the 17.7 and we get, let me see, 75,000 divided by that answer, 4233.13. 4233.13. There we go, and that's what P will equal. Now notice down here on these ones, it says now use the Tvm Solver Finance App. Let's see if we can find that. So we go to the apps, and here's a finance, Tvm Solver. Notice what it has here. The n, this is the number of periods. Notice that we've got to take n times y, like here where we got a 20, and here we got a 480, and there where we got a huge big number. That's our capital N. So let's go ahead and punch that in when we need to. Oh, they almost tricked us. That is so unfair. Number 9 here, we need to make sure and do this one over here. Number 9 is simple interest. We will not be using the Solver Finance app on simple interest. It always does compounded. So no app on this one, just calculator. That was almost tricky. So here we have that we know the amount is 25,000 equals principal is 15,000 times 1 plus RY. So 1 plus R times 15. Oh boy. This is an algebra equation we need to solve. So this is 25,000 equals 15,000 plus 15,000 times 15, that's 225,000 R. Okay, so subtract 15,000, we get 10,000 equals 225,000 times R. So we divide both sides by 225,000. Divided over here as well, 225,000. And let's see, the zeros will cancel. Zeros cancel over here. So 10 divided by 225. Let's pull that up and punch that in. 10 divided by 225. Enter. And this looks like the interest is going to be a 4.4% interest. There we go. Ooh, but that was tricky. I was all ready to do all those things, but simple interest is not valuable on this one. So now let's open up that app, get back to it. Apps, Finance, Tvm Solver. There we go. So on number 10, it says the capital N is the NY. So we're going to have 4 times, we don't know the years. So this is actually our question mark. So we don't know what this is, so let's just come back to that, and that's the one we're going to solve for. We're going to solve for the number of periods. All right, so let's put everything else. Interest rate. Don't change to a decimal. So in not changing to a decimal, the interest rate on this is 8%. So 8%. And you'll notice they leave this percent sign so they know that we don't change it. PV is the principal value. And it says that it is negative P. So in this case, negative 20,000. And it says because the initial investment is going away from you. The negative sign means the money is leaving us. All right, good. So now the payment. The payment, these problems don't have a regular payment. Put a 0. Yes, so this actually can solve all problems like, let's say you started with $20,000 and put $30 a month in. You'd put a negative 30 in there. Final value, FV, is A. That's the amount at the end of the time specified. So this is our 50,000. Okay. And payments or cycles per year or compoundings per year. And it says we're in quarterly, so that's 4. And notice it automatically changes them both. So we go back up to what we don't know. We kind of left that as just a number. And we hit alpha solve right down here, this in green letters. So we hit enter, but it means solve. And it says we've got to have 46 compoundings. So here, capital N equals 46 point blah, 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 blah. But notice that we've got to take, this is what N times Y is. So we've got to take that number and divide it by 4. So we've got to take 46.27 and divide it by 4. Let's quit out of here. And 46.27 divided by 4. And that's going to be 11.56. So the number of years, 11.6 years. That'd be an okay thing to write, 11.6 years. That's how long it's going to take. All right, now that we've kind of got the hang of that, we'll be able to run a little bit quicker through these. So back to the apps, Here we're looking for interest rate, so we're going to leave that blank. So first, the number of periods are going to be 12 times 30. That's 360 months. The interest rate, we don't know. We'll come back to that one. The principal, negative 13,000. Payment is going to be 0. The final value is going to be 100,000. So this is saying we're going to start with 13,000 and 100,000 is going to come back to us at the end of 30 years. What interest rate do we need? Now notice we need to make sure that this is 12. The number of compoundings per year, that's n. So we can't leave that. This is the little n. So we got to find out the interest rate, do alpha, solve. And it's got to be a 6.8% interest rate. There we go. All right, and the last one here. So notice that n equals 365. So let's go down through them. Ny, 365 times 35. That's how many compoundings we're going to have. It's 12,775. It's going to happen once a day. This is crazy. This is going to be a 2%. Good. Principal value is negative 20,000. Oops, I think I went one too many there. Is that right? 20,000. Good. No payment. The final value, we don't know. We're going to come back and do that, but this has 365 payments and compoundings per year. So let's go back up to the amount and alpha solve. And we get $40,274. 4274.28. And you should note that all of these, this calculator, if we didn't know P, or if we didn't know R, if we didn't know A, whichever one we don't know, if it asked how much did you need to start with, this allows you to find the missing variable. It's very valuable, and you should be able to solve those problems now. Good luck.